So I'm going to go ahead and begin the recording. Welcome for those of you who are joining us. I know we'll continue to have a few people joining us over the next couple of minutes, but we will go ahead and get started. And I'm going to ask, sorry for the repetition, for those of you who have been on for a few minutes, if you are just joining us, please type your name and the grade you teach if you're a teacher, or your organization if you're with an organization, so we can all see sort of who's here. We're really excited to have you together with us this morning as part of our fall series of teacher professional development opportunities, all focused on building student climate and environmental literacy. Even though we're all struggling to deal with the challenges of distance learning and this pandemic and how it's changed our lives in so many ways, there was so much momentum and interest around teaching and learning around climate change and building environmental literacy. And we know it's still urgent, and we are determined to keep that momentum going. My name's Teresa. I'm with Community Resources for Science. We're an organization here in the Bay Area that works to support educators and teach science. And so I welcome you all to be here with us today. And we have Eric, who's going to be our presenter, and he's going to introduce himself. And we have Betsy here, who's with the Natural History Museums, who's also part of our teacher professional development team. And we welcome you being with us here today. So Eric, I'm going to go ahead and turn it over to you.
Great. Thanks so much, Teresa, and thanks everyone for taking out some time.
I'm gonna run to the dollar store.
Yeah, we'll get started. We'll jump right in. So just first on your screens, you should be seeing a full Earth. So this was one of the most famous images that's being used today. I think it may be the most famous photograph that's been shared millions of times, probably billions of times at this point. It was taken by the last mission to go to the moon, the Apollo 17 mission. And they looked out of their rear portal and realized they had a full moon shot. So it's the first shot that was taken of the entire planet. And it actually was in tandem with when Earth Day started. So it kind of catalyzed this idea that we are one planet, we are one place. This is our home and we're the stewards. So I just really like this image. And it's got Africa there, so the origins of the human species, which is kind of neat too. So anyway, this is a great image, and you will all be getting access to this slideshow. So this image, although you can find it anywhere on the internet, honestly, but it'll be embedded right here in the slideshow. So we're gonna move forward. The title of our workshop today is Greenhouse Earth, and we're gonna look at atmospheric gases, the greenhouse effect, and climate change, and kind of tie those all together. And I just want to preface by saying, as we know, climate change is a huge topic, and we're not going to cover everything today. So we're only going to cover a fraction, but we, as Teresa mentioned, we're doing a whole fall series around climate change, and we would invite you to engage in the other programs that we offer. And there's going to be follow-up. So we'd like to do more, and we want to hear from you about what that more could look like. So we'll spend about an hour and a half today, and I wanted to just quickly look at our agenda and the team that's kind of on point today, and all of you as well. So our agenda, we'll do some quick introductions of each other, and then we'll kind of think about this as past, present, and future, big buckets in terms of how I'd like us to think about the program today and how we'll kind of run through things, both past, present, and future with respect to the Earth, but also with respect to yourselves and your teaching and what you've been doing, what you are doing, and what you intend to do so this year. So kind of think about it in a couple of ways. We'll roughly follow that game plan there, but we'll, I'm sure, undoubtedly jump back and forth. And then Teresa gave us a quick introduction to some of the team, but just to kind of give you a little bit more detail. We have a whole range of you here today, which we really appreciate, K-12 educators. This workshop was originally designed for 5th through 12th, but we recognize how important it is to start eco-literacy training and teaching at the youngest of ages, and would invite you, and so I'm glad you're here, if you are a K-5 educator or K-4, to think about how you might adapt and tweak the curriculum. And certainly self-enrichment is part of this process too. We're all learners. So having that background, regardless of the age levels that we're teaching, is super valuable. I'll be your presenter today, and I'll kind of give you a little bit of personal background and contextualize myself within this teaching space. And then our two folks that are on point from the team, our executive director, Teresa Barnett, introduced herself. And Betsy Miller is part of sorry, Betsy, I didn't get that right. She's one of my colleagues in teaching, and she works at the Museum of Natural History at UC Berkeley and does a lot of K-12 programming and working with grad students. And they'll be helping with overall logistics, monitoring, chat, tech support, things like that. So that's our team. And then just in the middle is that little star there. That's just a reminder to me that we're all in this together today, right? And so we want to encourage all voices to be heard. So we want to be active listeners as well as sharers. We could think of it as stepping into the conversation and sharing something, and then stepping out and listening and having your minds on those conversations and ideas that others are sharing too. Ways we can share, we're a small enough group that we can do some dialogue verbally. If it gets busy and we want to keep things moving, absolutely, please use that chat function to drop anything in there, because we are recording and we will save that chat, and all the ideas that you share there will be part of our archive from the program today. So really quickly, my background, I grew up in the Bay Area in Oakland and went through Oakland Public Schools, K-12. My wife is a public school teacher in Oakland right now in her 20th year doing kindergarten. I've had a exposure and a passion for the outdoors, environmental education since I was born. My parents would take us on these annual camping trips into the redwoods, which really kind of inspired me to embrace the environment and love it. I've do a lot of bicycling, especially right now during COVID. It's been a great relief and release to get out there and do that. Composting, gardening. Recently, a couple years ago, I attended a Global Climate Action Summit, which was state sponsored, and it was a great chance for folks to come together and convene. And I just completed this thing called the Climate Reality Corps Leadership Training, and I'm wearing my little, in addition to my NASA sweatshirt, this is for you all. It's a little green pin, which may not look like much. It's a little green circle, but that means I'm part of this team of 30,000 people around the world that do voluntary presentations and about climate change and what we can do about it. And just really education is so important, as we know. So really been dedicated to this space for 25 plus years, have taught informally for about that length of time, about 25 years. So we're gonna move forward. Our goals today for the workshop. So what we'd like to do, again, climate change is a huge topic, but we do want to spend some time with content and really give you an opportunity to learn a little bit more about some climate science concepts, ask questions, think about teaching and learning techniques, what we can do, especially during this distance learning environment. How can we engage our learners in active ways when we actually aren't in the same room with them? So think about those two things, the classic ways that we engage our students and how we do it with this platform in mind. Hopefully make some curriculum connections. So what are you doing? How does what we talk about maybe potentially scaffold on to some of the things you're working on? And then that can then therefore turn into a plan of action. So those are kind of our large scale goals. And again, really encouraging us to jump in and learn together. So we're going to start with one of those engagement techniques I'm sure many of you have used, which is this idea of a KWL. What do we already know about a topic? What would you like to know today? Something a little bit more, something you've been curious about. And then at the end, just spending some time reflecting on what we covered, what we learned, and how we might then use that information to take the next step. So think about those things as we're going through today. And if you could just spend a couple of minutes addressing those first two questions. If you'd like to unmute your mic and share it verbally, I think we can do that, but certainly drop ideas into the chat as well. And I know Teresa and Betsy are helping monitor that chat, and we'll call out anything that sounds interesting. So go ahead and take a minute. And you can put this in the frame. You can think about this not only for yourself as a learner, but as your students. Like, what do your students already know? In this case, we're saying the atmosphere as our first topic this morning. What do your students or you know about the atmosphere already? and maybe something that you or they might like to know.
So for me, I already know that the Earth's atmosphere has changed since the Earth first began, that there have been changes over time. What I would like to know is, how do I take all this information that I have about climate change and put it into things that the kids can really grasp on to at this point?
Great.
This is Nate from New Mexico, and we just finished in biology the greenhouse gases, and I'm high school, and I was surprised that most of my students didn't know too much about greenhouse gases. And coming out of ninth grade physical science, you would think that they would know more, but it was almost like starting all over again in biology, talking about greenhouse gases and the atmosphere. So it's a unit that I need to revisit again with these particular students. And we did, I turned on the NASA website when they did do the venue for the asteroid. That was pretty cool to them, just going outside Earth atmosphere to collect that. And they was amazed that it's going to take 2 to 3 years for it to come back. So, well, you got to look at distance. So what would I like my students to know? I like for my students to know a little bit more about the Earth atmosphere before they get into biology.
Yeah.
Great. Thank you for joining us all the way from New Mexico. That's one of the great bonuses of distance learning, is we can drop
There's
in.
2 of us. Deborah Grader is also from New Mexico.
Great, great. And Teresa or Betsy, anything you wanted to call out from chat?
Well, there's an interesting one that says that the atmosphere is connected to and affects all other spheres, the biosphere, the geosphere, and the hydrosphere, which kind of builds on what Nate said about wanting them to understand the atmosphere before launching into biology. And then that we are the stewards of the atmosphere. And what does that mean for our days, our day-to-day lives? So it's a pretty important part of the world. It makes living on Earth possible. There's a lot of really good stuff in here.
One other that I'll just call out is the connection to the math. So how can we incorporate thinking about these issues across the curriculum a little bit? And someone's asking about thinking about how to, if you're doing a math lesson and you're looking at data, using that as an opportunity to bring in some climate data to incorporate into the math lesson. So you're building skills and knowledge at the same time.
And I think another point is that we talk a lot about climate change, and it's can be a scary thing. So how do we approach this subject without scaring the students? Make it give a positive spin, or at least some empowering people to deal with the problems that we have. So it's not so scary. That's a common.
And another thing, I'm in New Mexico, and the students, they don't realize that the fires in California affects them. So that was a big thing to them when I brought that out, was even though we are far from California, the smoke is coming towards us as well. I mean, up in Albuquerque, New Mexico, they had a very poor air quality rating a couple of weeks ago because they're getting hit from both sides. There's a huge fire in Colorado, and then the smoke from Arizona and California is coming as well. And we get touched too, even though we up in the mountain in New Mexico, just to have them realize that just because we are not there, it still affects us indirectly or directly.
Yeah, thanks everyone for sharing. These are great and reminders that the world is one place, and now experientially we're feeling that. And so, and yet, we're going to move forward with our first kind of thinking about how we start to grapple with this and understand it. So what I'd like us to do is continue this KWL by having you use some of the materials. And this was the short materials that we asked you to gather, most of which are very easy. The last one, a large group of multicolored objects, manipulatives. If you've got that, great. If you don't sweat it. You know, we can move forward with the other supplies that you have at hand. So So really quickly, literally in about 2 minutes, I would like you to just create a quick drawing of Earth's atmosphere on your note paper or in your notebook. So just spend a minute or two drawing a picture that represents the Earth's atmosphere. That picture can include words as well, anything you like. It doesn't just have to be a literal picture, but anything that you'd like to just put down quickly. And if you've got one already done, feel free to hold it up to your camera. And if you'd like to share it with the group, if you're so bold as to put up your artistry and share it with the team, we'd love to see it.
Just open this.
Well, give yourself, and we're going to continue on with this this piece that you're creating. So don't worry if it's not exactly as you want it yet. But is anyone, one or two folks that would like to maybe share what you've got, just so the rest of the team can see? And I recognize we're just using a camera, which, you know, sometimes that's challenging, but it's a great quick way to share information. Oh, I see one going up. All right. Do you want to tell us a little bit about what we're seeing there? You can unmute
Well,
it.
it's the whole idea that, you know, it's back and forth between the water, and between the earth, and also that the sun is affecting it.
Great. Love it. Nice. One more share out there. Anybody else like to show us what you've got in your notebook there? And thank you, Terry, for jumping in and being our brave first. It's always hard sometimes to be that first. Karen, what have we got? Tell us a little bit about what you've drawn. This looks great.
Karen, you might be muted. I think I can unmute you. There you go.
Okay, I unmuted. Okay, so the planet Earth, and then the atmosphere is like gases surrounding the Earth, so it's like a blanket surrounding us. So that's a way that we're getting greenhouse gases getting stuck.
Well, thank you, and hold on to those drawings, because we're gonna be using those and referencing those throughout the workshop. So what you've done, believe it or not, is you've just created your first model of the atmosphere. Sometimes we think of models in different ways, right? We think of them as a physical thing that I can hold on to or manipulate with my hands. But a drawing is actually a really nice, simple example of a model. And models are so important. As we know, California in particular has adopted the next generation science standards, and we see models come up throughout those standards and in a couple of the dimensions. And I know Betsy and Teresa were going to speak to this idea that it's not just one place that it shows up.
Well, just briefly, I'll jump in and mention, I think Betsy might be working on putting some links in, but we'll share some links out for sure with you following this. But just as we're going through this and talking about models, just thinking about the fact that in the next gen science standards, using models is a science and engineering practice, and a cross-cutting concepts is thinking about the interconnection of things, systems and system models. So models appears and is used in two kind of different ways, in interconnected ways in NGSS, and we will share with you some links that have really the grade level progression, so you can dig in if you want to learn a little bit more about that. We're not going to delve into it too much in today's session, but we're just acknowledging that for you.
Great, thanks, Teresa. And so models, as we're kind of talking about, let's think about it, let's frame it this way. Some of the questions we want to think about: what are they? What are some different types? How do you use them with your students? What are some strengths and weaknesses of models? And so that's kind of our framing discussion questions. So think about those as we kind of move forward and develop out our models together, starting with the one that you just created. And then again, please feel free to jump in and share things in chat as well if we can't get to all the great ideas that you'll have. So definition of a model. So just look this up online. A scientific model is a physical or mathematical and or conceptual representation of a system of ideas, events, or processes. And oftentimes we use models to depict something that's hard for us to get our hands around. Maybe it's way too small, like that model of the cell, a human cell that you see there on the upper right. Or maybe it's something really big, like the solar system, right? That we conceptually can't see it all at once, but we want to figure out how things are related to each other and what's going on. So like, I love the way that Terry shared that sun and earth interaction, right? We know they interact, but that's a huge system right there. Or a house, building a small model of a house to inform maybe the positions of the rooms or the furniture we want. And there's different types of models. The picture that you just drew, the sketch, maybe you've got some words on there so we could think of it as a diagram. Maybe it's an animated model, like the lower right-hand example of a Rube Goldberg machine, where we can't see the whole thing, but we see the dominoes leading to the marble rolling, leading to the next thing. So it's a nice animated model. Physical models. So we'll spend some time teasing that one out a little bit. Those are probably the ones we might be most familiar with when we think about a model. And then I would say most importantly are our mental models, because our mental model is something that no one else can see but us, and no one else understands. But to get to those other ones, we need to get that mental model out and depict it in some way. And if we are exposed to other people's models, other ideas, other scientific models, it can bolster and inform our models and our conceptual understandings, our mental models, and then we can iterate and build a more robust model. And then there may be others that you can think of as well. So thinking about that, let's take the model you just developed and let's refine it, because this is kind of the process that NGSS engages us in. It's not just to build or use a model, it's to actually create our own. So we get to be behind the scenes. We get to be sort of on the back of the stage, manipulating these things and really getting them to work for us. Because again, it's about getting our mental models developed and using those mental muscles to develop something that gets closer to the truth. So I've given you a little more information about the Earth's atmosphere. So taking what you see on the screen and the supplies in front of you, which can now include those objects that you're manipulating, those multicolored objects, perhaps your colored markers you might have there, or anything honestly in your, I'm going to call it your laboratory, anything in your house around you. If you've got something that you think would bolster your model based on this new information, please feel free to take a minute or two and refine your model based on what you're seeing here.
So using the new information, add to the model.
Yeah. So and I won't even yet reflect on what we're seeing, but just kind of visually looking at what's on the screen and how might that inform the model that you've developed already. And just another minute or so. And by the way, we recognize we're covering a lot of ground today. So when I teach a school group, I really like the idea of the questioning strategy, putting the questions in their hands, having them popcorn out, turn and talk, group sharing before, small group sharing before large group. So we're moving quickly and I'll try and model some of those with you, but think of these concepts that we're talking about as stretching over, a number of weeks, a number of months, for Nate from New Mexico, just thinking about those students in high school that, you know, have a lot of background already, and yet this idea of greenhouse gases was new information, and it takes a long time to build understanding around some of these concepts. And climate change is so interdisciplinary and integrative, am I saying that right? That, you know, we need to take the baby steps to get to the sort of holistic understanding. Would anybody, and I recognize now if you've created now some physical pieces of your model, it might be difficult to share, but if you'd like to aim your camera, or maybe there's somebody new that didn't share initially, would anybody like to share your refined model with the team? And if it's too hard to show us through the camera, you can talk us through it too.
I unmuted. So I redrew this, and then before I saw your other model, Eric, so my coloring's a little bit off, but I added just proportionately the number nitrogen for the blue, and then carbon dioxide green, and then I have too much other gases in here because I did that before we did it, and then whatever the purple is. So.
Tell us a little bit more about that word proportional. I loved how you brought that in.
Oh, okay. So before I even knew what we were doing, I redrew the first thing I did on a little scratch paper. So I wanted to add more gases, but I didn't think about proportionately how much of each was in the air, you know. So my model is a little bit off for me, but it represents that there are a variety of gases surrounding. Yeah.
And proportionally, which one did you depict? Would you, if you were to start over and, you know, knowing what you're saying, what would be the highest percentage or the highest proportion gas?
Nitrogen, the blue,
okay,
which I had most of, but yeah, it's my other gases is way too many if I was to color coded.
And this is all part of this iterative process, right? We learn as we go and we rebuild and great. And a second share, anybody else that would like to share a little bit about what you did? These are fantastic.
Don't be shy.
Mm-hmm.
This is really important for students to do, to look at each other's models, because they can excuse me, learn a lot from each other and go back and use that information also to revise. So it's a really great way to get sharing and continue to build models. So if somebody was going to share.
I can share what I have, and I haven't really added anything yet to my initial model, but what came up for me because of this chart were just some questions, because I've been thinking about the layers of the atmosphere. So my model has the troposphere up through the exosphere, and then I just put like my concern about gases coming up from the earth and you know, human caused effects on the atmosphere, and then heat coming from the sun and how they interact through all these layers, which I don't really understand the effect of the layers on each other. But then looking at these percentages, what started coming up for me is, I know carbon dioxide is increasing, and how does that increase cause changes in the other gases? Mm-hmm. So I don't know how to put this in here yet, but that's kind of where I am right now.
Great. Thanks, Kate. We won't get into, for lack of time, the structure of the atmosphere, but it is a great place to go and a great building block to understanding the whole thing. Those 4 principal layers, what they do. You know, each layer turns out has kind of a function. Most of the atmosphere being down in the troposphere, you know, well over 90% of the atmosphere is stuffed at the surface in that what we call the troposphere, and then we can move up out into space. But thank you for bringing that in.
And Eric, just as you're getting ready to transition to the next step, I just want to call out that we did throw a question in the chat as teachers have do this activity and have a little bit of a moment to reflect how they use models right now with their own students. And we're seeing some nice suggestions come into the chat. So, you know, as an idea comes to you in terms of how you're using models with your students, or you have questions about using models with your students, feel free to just, as Eric said at the beginning, drop those in the chat and we will keep monitoring those, and they'll be included in the kind of follow-up information we will share out too.
And that's a reminder to me too that, you know, the atmosphere, like the solar system, is hard to visualize, right? We can't see it. The atmospheric gases for the most part are transparent. So building models to understand them can really help us out. So thank you. Thanks, Teresa, for capturing those broader ideas about models too. So we're going to move forward, and we're going to jump now from this idea of the atmosphere into a beginning conversation about climate. And I'm going to engage you in an activity. This is actually personal to me because this is how I became interested in this topic at the very beginning during college. So what I'd like you to do is look at this world map, and we're going to do a really quick I notice and I wonder. So if you could just look at this map, and again, populate the chat here with something maybe you notice and something that gets you to wonder about. We'll spend maybe a minute or two there. Well, I see some great stuff coming in. I'm going to call out Tracy's real quick. The different colors representing different biomes. Great.
Couple of interesting questions about population in the different areas. So the connections, maybe starting to think about where people are.
I think an interesting observation is that it's a lot polar. The tropical regions are variable. So there's a, the top is kind of all uniform, but in the middle, you get a lot more variety happening in terms of the kinds of climates that are present. Kind of hard pattern to interpret. Wonder what's going on.
Mm-hmm. That's reminding me too that I'm seeing some questions about the map and when it was made. And this is called a Mercator projection. So basically it's a map of Earth being a sphere. This has been sort of flattened out into a rectangular projection. And the problem with these maps, so this would be a weakness of this model, this pictorial model, is that it distorts the poles. It makes the poles look way bigger than they actually are in relationship to the equator. So as you move poleward, everything gets bigger than it should be. So that blue that we're seeing at the top is much more than it actually would be. Greenland is not that big in relationship to the US, for example. And then yesterday when we were doing this, was Betsy or Teresa noticed, Antarctica is not even on here. It's missing, right? The whole southern pole. So this model, doesn't work in some regards, right? But it does show some interesting things.
And I think that gets to the point that you were asking on your original slide about models, right? Thinking about and talking with your students about the strengths of a model and the weaknesses, right? Why we've used something and what it's able to represent, and the weaknesses in terms of ways that it doesn't fully capture the real world. So those are great opportunities to explore those things about models as well whenever using them.
And one way that geographers have gotten around is that they've created these different types of projections that are flat, but they do a better job at being true to the area of the different parts of the world. So you can find those are more complex projections, but they're interesting to look at. And they, again, what's the purpose of the model? What's your intention? Because, so let me show you where I went with this when I saw a map like this in my sophomore year in geography. So one of the things that stood out to me was, if you look at the 5 boxes I've kind of outlined parts of the world on, and you find California in that sort of that upper left corner of the map, we're in a climate zone called the Mediterranean climate zone, which we have, as we know in California, cool, wet winters typically, although unfortunately this year we're not getting the rain as early as we would have hoped. and warm, dry summers. That's kind of the play pattern of our climate. And when I saw this map for the first time in that geography class in my sophomore year of college, I noticed that there were 4 other regions around the world that had the same kind of climate. So that got me asking all kinds of questions. So I noticed that, and then I started wondering, well, what is climate in the first place? Why would these regions have the same climate as us? What's going on there? And just personally, I'd love to visit those places and check them out and see, are they similar? What are their biomes like? What does the landscape look like? What's going on? So what's driving the fact that there's 4 other climates that are very similar to ours? And that just pulled me into this space, like completely, like, wow, that's pretty cool. And so, that's, I think those entry points for students can be really interesting. You never know where you're going to hit one. It's like that little light bulb goes off and that engages them in science, and then they start running with it. So look for those places of inspiration, and you can really propel learning when you latch onto those, I think. So climate. So just some basics about climate. So we've got these different regions of the earth that are experiencing different types of climate, like polar climates, where it's very cold, desert climates, where it's like the Sahara Desert, where it's very dry, or our climate, which is kind of a hybrid, right? We can get warm, but we can also get cold. We can be dry, but we can also be wet. So weather versus climate, kind of a basic idea, right? But sometimes it's hard to get our heads around. A really common analogy that I have heard used a lot is weather is what I'm going to wear today. I wore this sweatshirt not only because it said NASA and I wanted to show it off for you all, because NASA is a great resource for data, but because it's a little cool up here where I am. So I wore that today. That was my choice. But what I would buy for the season would be different, right? Because I know it's likely going to start getting cooler and cooler. So I better, if I don't have a good jacket, I better go buy one. So I'm planning for the climate. But the weather's what I deal with day to day. Likely I'll take the sweatshirt off later because the weather's going to warm up. So that's one really quick and dirty analogy for how to think about the difference between weather and climate. And then another building block for climate is something we call the greenhouse effect. So I pulled this real quick animated model off of the NASA website. And it's kind of what we saw early on, we talked about some of your models that you built, is that the sun-Earth system is the big driver of our climate system, right? We need an energy input, that being the sun. Sunlight comes in as sort of full spectrum light, high energy light, and then it bounces off of surfaces. Some of it goes right back to space. Some of it, though, as it bounces off, it's radiated out as infrared or low energy light, and then it gets trapped by parts of our atmosphere, but not the whole atmosphere. So there's an energy input and there's a retention of heat around the planet due to our atmosphere, is the basics of that. And that's called the greenhouse effect. Another driver of climate and weather, but are 2 other concepts that you may not hit until high school truly and be able to visualize these, but they're called Hadley cells and the Coriolis effect. So Hadley cells, the idea here is that because the equator is typically pointing towards the sun much more directly than the poles are, you get differential heating. So the equator heats up a lot more on average than the poles. And so when you get a difference in temperature, you also get a difference in pressure. So the pressure at the equator is higher typically, and that it wants to move towards the low pressure zone. So essentially high heat, high pressure moving towards the poles. That's the overall sort of flow of energy in our whole Earth system. So that's a huge driver of energy, because where you have energy moving and air moving, you get wind, right? And you get motion. So that's a big driver. And now if the Earth wasn't doing anything else but just sitting there, then you'd get this equator to poleward transfer of energy, either north or south, and it would be kind of stagnant. It would just be sort of this straight line, these sort of flowing cells, these things called Hadley cells. But now we got to add on another piece of motion, which we call the Coriolis effect. That's when the Earth is spinning on its axis. So what that does is it takes that motion that's going poleward and it skews it, and we get weather patterns that typically go from west to east because of the spin of our planet. So you've got this heat transfer going on due to differential heating from the sun and the interaction with the atmosphere, and you've got a rotating planet which is driving this sort of bending of our weather. And that's what causes cyclonic activity too, by the way. So you get a full, because of the Coriolis effect, you'll get hurricanes, tornadoes, spinning systems, right? High pressure zones and low pressure zones. So again, this is a real quick and dirty, just like what's driving climate. This is like a whole unit that you could spend a deep dive on, especially in high school. But just these are some of the big drivers of climate. So then I want us to think now about sort of the next piece of this. So we've got drivers of climate. Spend a minute just kind of reflecting on this question. How do you think the Earth's atmosphere and climate have changed over time? And one of you, I think, had already sort of asked this question earlier, was wondering, well, how has it changed? So just spend a minute reflecting on that. And again, if you'd like to drop anything into the chat, please feel free to do so.
Yeah, there's an interesting comment. My son lives in Hawaii, and I can tell what weather I will get here before it gets here by what's happening there. Just really reflecting those movements that you're talking about, Eric.
Nice. So being that Hawaii being sort of further west of us and the driving prevailing winds coming this direction towards California. Great. And also that smoke, just making a connection to what Nate was talking about earlier. You know, we saw a lot of the smoke from our intense wildfires this year, making it all the way to the East Coast. You know, so again, prevailing winds driving that smoke in the upper atmosphere towards, you know, 3,000 miles away towards Washington, D.C. Or us getting the Australian wildfire smoke earlier, you know, in the year. Great. I'm going to peek in chat too, but anything else? Or okay, so Tracy kind of coming up in with I wonder if things have changed over billions of years. Catherine asking about populations in certain climate areas.
Yeah, I think, and a lot of them are actually personal changes that we see. Summers are getting hotter and drier, so that's a personal thing. And greenhouse gas increasing. Those are things that we are seeing in our lifetimes, like personal connection to that.
And I'll just jump in as people are thinking and typing in their comments. Betsy shared in the chat 3 resources that you might want to bookmark. We're going to have a break coming up in a couple minutes, so you could use that to bookmark those things that are really great sources of information for engaging your students. They're very accessible and they have lots of nice charts and visualizations, to someone's point about incorporating data. So those are some great resources you might want to bookmark. We don't have time to go into them right now, but
I'm going to call out one more, then I'm going to get us into our break, maybe a minute or 2 late, but we'll get close. Kate, the climate and atmosphere change very slowly through natural processes and cycles, and sometimes very quickly through catastrophic events. So that's true on all counts, and thank you for sharing that, Kate. That's really interesting. Here's what I dug out of the NOAA website. It put our atmosphere history in 3 buckets. It called it Atmosphere 1, which at the birth of the Earth, say 4.5 billion years ago, things were mostly hydrogen and helium, the 2 lightest gases, the 2 lightest elements that exist. And everything was kind of coming from that initial sun, you know, being kind of born, if you will, sort of igniting. And then there's hydrogen. There was sort of this cloud of material that ultimately formed the planets, right? And most of that stuff was hydrogen and helium until things started merging. And then we got to a situation where the main driver was not the origination of the solar system, but atmosphere 2 was driven by volcanology on our planet. And volcanoes spew out different kinds of gases. So things like carbon dioxide, water vapor, NH3, ammonia. So those became the principal gases in what we call atmosphere 2. And then we get to today, and what changed between the sort of the volcano world of the first billion years or so to now is life came on the scene, starting in the oceans and ultimately migrating out onto the land as the atmosphere became adaptable or became protective with an ozone layer to allow life to get onto the land. And then those living things started actually influencing the atmosphere itself. And we got to a mainly oxygen and nitrogen atmosphere, like we talked about when we developed our models and refined them. So that's kind of where we are. But to Kate's point, there's been huge, events in there that have been catastrophic, like what got the dinosaurs, the big impact, 65 million years ago, which completely changed the atmosphere all at once and all of a sudden. So absolutely, there's these pulse events that can have influences as well. But that's sort of, again, very quick and dirty. There's a lot here that we're not going to unpack today, but just kind of big picture. So now getting back to climate change, before we go into break, I'd like you to think about this during break. Those Mediterranean climate zones that fascinated me and pulled me into the climate change education and teaching space. I've been doing some deep diving in the last, especially during COVID, you get a chance to kind of look at stuff and learn more. I've been looking at those other 4 regions and asking questions like, what's going on? So what's happening in Chile, central Chile? What's happening in Australia? What's happening in Cape Town, South Africa, or the Mediterranean region of Europe and Africa? And it turns out they're all experiencing climatic changes, and many of them are very similar to California. Australian wildfires, we remember those from January. Santiago, Chile is in the middle of a mega drought, a drought that's lasted almost 10 years. Cape Town, South Africa, the reservoirs, the 6 freshwater reservoirs that they depend on almost emptied in 2018 because of the drought that they're in. And then wildfires throughout the Mediterranean region. So we're all, for better or for worse, I suppose, but it's informative too. We're all experiencing climatic changes. So it's not just unique to California. Our climate analogs are experiencing similar changes. And then other parts of the world likewise are experiencing changes. So we're seeing the empirical evidence across the globe and it's accelerating. So we know that, we see that. And these are some of the impacts for us locally, the wildfires leading to, honestly, the worst air quality that we've experienced in my lifetime. In the last 5 years, it's been just so dramatic. Reservoirs being depleted. And then the trend line, this is a NASA graph, just, seeing that the average temperature across the globe are going up. So that's just what's happening, but and we see it, we know it's happening. Now it's the question is, what do we do about it, right? And how do we move from here? So I'm going to leave us there, and I'm just going to I'm going to bring this graph up after break, but this is going to get us a little more detail about our atmosphere. So we're going to take a 5-minute break. I'm going to start our little clock here, take a stretch, fill the coffee cup, do what you need to do, and we'll see you back in 5.
And we're here if anyone has any questions or wants to ask anything.
I'll be back. I'm going to take my own advice, fill the coffee cup.
Sounds good.
Glad you mentioned that, because that's something that we've been talking about as a team, to create an entire follow-up workshop that's really focused on solutions. Because so many of the conversations I've been in with kids and educators is they don't want the last 5% of your curriculum to be, oh, and you could do this or do that and go figure it out. They want to know right now what I can do to create a positive future, and just be able to visualize themselves, in 2050 in a place that, yes, the world honestly is going to change, but it doesn't all have to be for the bad. And we're all part of that, visualizing and creating that path to get there.
One thing I found is like getting them locally involved in something, anything, like teaching other kids what they know. And, like we do like fish in the classroom, or we did the otter thing yesterday. If there's a way to hook into those local things, they start feeling like they have some kind of agency. So.
Yeah. I think it's also important to just remember that a lot of basic science that we teach is environmental literacy and is climate literacy. And yeah, the problems will come up, but really that foundational work that you do in the classroom is so important in terms of bringing them to understanding what the basic processes are. So then we can get to solutions.
Yeah.
So I just don't want to forget that the basic science is climate science too.
Yeah.
You know.
So we're gonna move forward because we do want to get you to this one really hands, or at least mine's in and hands on your mice to get to do the activity. But again, thinking about our model, and I think we're going to not have you refine your model further physically from this information, but would anybody like to just, I wonder something from what you're seeing on the screen. So I'm giving you a little more information about Earth's atmosphere here. Quite a bit more information, I guess.
So why is carbon dioxide listed in trace gases and on as one part of the gases? Or is the other one just carbon?
Good question. So what we're seeing, if you look at that left hand, let me see if I can get this laser pointer going here. That's a neat feature. Here it is. Okay. So this graph is one we got introduced to that shows us the majority gases, right? So 99% of our atmosphere is nitrogen and oxygen. The remaining 1% is mostly argon. So that leaves us with 0.1% of everything else. So that graph you're seeing on the right, this one here, is a blow up of what's left. So of that trace amount of gas, the majority of that is carbon dioxide. With the caveat, I will say this, water vapor is left out oftentimes in these breakdowns of the atmosphere, and that's intentional because water is a condensable gas. It's the only condensable gas at our average temperature in the atmosphere. It's constantly fluctuating. Over the desert, it's near zero. In the rainforest, it might be upwards of 4% of the overall atmosphere at the time. And it turns out it is the strongest, most influential greenhouse gas. But we don't directly influence its abundance. And we'll talk about that parking lot that later. But the thing to notice here, as you said, is that carbon dioxide of the trace gases, it's the majority. And then the other thing I want to point out, moving us forward, is the greenhouse gases on the left here comprise only 0.1% of our overall atmosphere. Those are the ones that are responsible for heating the Earth 50 degrees. So without them, we're a frozen world. And it's a really small amount of gases that are causing that. All these ones up here, because they're diatomic and they're the same. So hydrogen, H2, N2, O2, argon, and noble gas, they don't absorb and radiate infrared light. So it just passes right through them. Non-greenhouse gases. So that was a huge aha moment for me when we talk about these changing gases in the atmosphere, when it's only such a small percentage influencing such a dramatic temperature increase of the world. You can kind of start to fathom, yeah, atmosphere is big, but I could actually fathom that, oh, changing some of those could actually have an impact on our average temperature and therefore climate. So what if we could visualize CO2? This is the other problem with climate change. It's hard to see what's going on. So this is a quick narrated video from Neil deGrasse Tyson. Uh-oh, sorry. Is that, wait. Got this to work yesterday.
If our eyes were sensitive to CO2, and perhaps there are such beings in the cosmos, if we could see all that carbon dioxide, then we would overcome the denial and grasp the magnitude of our impact on the atmosphere.
Okay, so we know that humans are influencing the atmosphere. Now this is another, another video. It's about 3.5 minutes. It's not narrated. So just follow along with the subtitles and notice, this is something that a scientist called Charles Keeling discovered starting in the 50s. All right, so oops, let that run. So there's a lot there to unpack, but we want to drop you into our interactive activity. So I think the one thing that I just want us to think about a little bit is human influence on the atmosphere based on that video and the empirical evidence that we're seeing, because not only do we know the sources of the additional carbon dioxide, but we know the origins due to something called isotopic kind of tracking. We know that it's coming from fossil fuels that were stored in the ground. So there's ways that we know the origin of that CO2 very definitively. And so we're going to jump into a Jamboard activity. Just a quick show of hands, who's used Jamboard already in your classrooms? Just curious if you're familiar with that. It's a great tool, and I will be honest, I'm just learning how to use it, and I love it. So what we're going to do, and this is kind of to Nate's beginning comment about greenhouse gases, we're going to take a moment to each become an expert on a greenhouse gas, a beginning expert, if you will. So our objectives are to learn more about them and to put the A in STEAM, right? So we're going to add the art to STEM and call it STEAM by creating an engaging pictorial display of a greenhouse gas. And the example on the screen is carbon dioxide. The way we're going to do this is we're going to drop you into breakout rooms, and based on your breakout room number, we'd like you to work on that board. So carbon dioxide is room 1, for example, and they're in alphabetical order. Chlorofluorocarbons is room 2. You'll kind of make the connection. You'll work in teams of 2 or 3, and it's a very simple activity. You're going to replace the labels. So in this case, there's 6 labels. You're going to replace those with information, images, things that you source from the image database within Jamboard or online, up to you. You can divide and conquer this. So each of you take 2 and go find them and bring them back for the team and drop them in. And we're just trying to make a visually engaging presentation that then ultimately you can go around, and the last step will be you're going to visit the other 5 Jamboards for the other 5 greenhouse gases, see what folks have done and leave little comments. Use the post-it note feature in Jamboard to do that. the link we're going to drop into chat. Did you all, Teresa or Betsy, already do that?
Yes, the link is dropped into chat, so everyone should be able to be going there now. So let's make sure that everybody's able to get on to that Jamboard before we send you out. But we will also hop around into the rooms and see how things are going. And I'm going to say, Eric, I'm going to just jump in and say, because seems like a really great group, we're going to not waste time bringing you back and forth, back to the main group and then back to the Jamboard. We're going to use the broadcast feature and kind of walk you through the steps. Now it's time to do this. Now it's time to do that. So we'll send that information out to you. But I think the important thing for getting started is you're in groups of 2 or 3, and we're going to ask you to find the breakout room, find your breakout room number when you're moved. You should see it at the top as you're getting moved to a breakout room, and find that page in the Jamboard. So that'll be the first place where you start. So if you're in breakout room 5, go to page 5 on the Jamboard. And then you're going to do the activity as Eric described, replacing the words that are there with images or some text. And then we're going to send you some instructions as the time proceeds. And then later on, we'll ask you to go to some other pages and do some reflecting and thinking. But your first step, find the Jamboard page that corresponds with your breakout room and go ahead and fill in the information about that particular gas that's on that page. Any questions before we send you?
And one last thing I'll say, I like to do these activities where I don't give examples, just so I don't, take away from the creativity of our students and our learners. If you need a little bit of inspiration, there is an example one at the end. Feel free to find that and just reference it, but I'd encourage you not to if you feel like you can just create something fun. And you're only going to have about 5 minutes to kind of get this going before we go to the next piece.
But you'll be in your breakout rooms together for about the next 15 minutes or so, because we're as always, as all of you teachers struggle with, and the time is never as much as you want it to be. So we're going to send you to breakout rooms now, and Betsy and Eric and I will pop into the different breakout rooms. So if anybody's confused or having questions, we'll
I do. Where can we find the
Jamboard?
The slides? No, the Jamboard I got there, but you say to know which group you are in beside the breakout room.
When you get the invitation, it'll tell you you're going to breakout room 3. And when you're in the breakout room, you should see it on the top. So if you're in breakout room 3, look for page 3 on the Jamboard.
I don't know. Okay, the Jamboard, I only see one page, so I'm just curious.
There's arrows that you should be able to see, the arrows next to that number on the top. You see the arrows that you can navigate. It should be opening. You should be on page 1 of 14. You see that? And there's little arrows next to that help you navigate to page 2, page 3, and so forth.
Okay. I don't see it yet, but okay.
When you get sent over, you can explore.
Okay.
So yeah, so kind of you go to your breakout room and then just click on the link to the Jamboard pages, and we can talk you through it too.
Okay, great. So I'm going to send people off to their breakout rooms, and we will check in on you. Eric, there are 6 breakout rooms, which means that I think the one that doesn't get answered there is water vapor, maybe? I don't know how many gases you had set up.
There's 6.
Oh, okay.
There's 6, so that's perfect.
Perfect. Perfect. And so if you want to navigate into any of those rooms, you can. Terry, who's in breakout 6, said that sometimes it doesn't work because she's remote in Calaveras and the delay is too slow. I don't know if that'll be the case for her today, but I said someone would pop in and check with her. So Betsy, can I stick you in room 6? And
And so let me just make sure I'm clear on, they're going to spend 5 minutes building their Jamboard, and then they're going to go on and talk about.
And then we will broadcast to that next step, which is doing a little bit of a gallery walk and
Okay,
looking
got
at
it.
the others.
Okay.
And then we will go ahead and broadcast now,
discuss
go to
solutions.
7 and answer those questions using
Got
sticky notes 8 and so forth.
And those,
Okay, yeah.
and those are
You
less
can send me there.
focused on those 3 broad questions are less focused on the solutions, which was where we were going to go originally, and more about what they've done, what they'd like to do, and what they need to get to do it. So
Teresa, are you still recording, by the way?
Yeah, but I can turn that.
But
We're not-
it'll go with you if you go into a room, so you might want to have it on, and then you can capture some of the.
Okay, great.
Okay, so you're going to send me.
Like, some of my students will be complaining, why I didn't finish? Why do I have to go back to the main room? I feel like sometimes as a grown up, we feel like that way too.
Yeah, exactly. Well, the great thing is we're bringing you back from the breakout rooms where we hope to give you that nice big chunk of time to just be having some small group conversations with your colleagues. But we are all still on the Jamboard, and you can still all have access to it, and you will have access to it after this session. So we're just trying to be mindful and respectful of people's time about ending at the 11:30 time as we promised, but we are still available to hang out, and you can stay on this Jamboard and continue to share things or come back to it later. You'll continue to have access to this. So we don't want you to feel rushed, but we wanted to share this tool, this resource, this activity with you as a way to share and explore and facilitate some smaller group conversations. And particularly before you go, or at some point in the next day or two, be sure to add to that, what do you need? Because that'll help us shape what else we offer, what kinds of things we can support you with following up. All right, Eric, we have like a minute or 2 left. How would you like to wrap it up?
We'll bring everybody back, Teresa.
Yes, everybody has come back.
Okay, so let's let me do that. And great. So welcome back, everyone. I know that was a lot to sort of digest in a very short amount of time, but I had some good conversation with folks in one of the breakout room I was principally in, and I would encourage you to take an activity like this and use it, fit it in the way it fits for you. So like we had 6 things you were looking for, right? And we did this team approach. Maybe you start with 2, maybe it's only like the chemical formula and the molecular equation, the diagrams, because that's where you're at. And then build from there. And maybe you spend 15 or 20 minutes on it in a period and move forward. So, or use it as the capstone project. After you've covered everything you want to cover about greenhouse gases, now they get a chance to display their work and share it out with their colleagues and have some good scientific dialogue. So there's so many ways, don't feel like you need to do it. To make it work for you. So for next steps, as Teresa mentioned, there's those 3 prompts questions. So on Jamboards, I believe it's 7, 8, and 9. There are prompting questions about what you've done, what you would like to do, and the resources that you need to get you there in the near term, like what would help and how can CRS be a part of that support for you for this year. We have a few things that we're working on at CRS specifically just to call out. There are more workshops coming, so please jump in. They're all at no cost on either Thursday afternoons or Saturday mornings. We would like to do is start some learning communities around various topics, including climate science. And what would that look like? How often would we meet? What would be the goals of the learning community? Would we bracket it by primary and secondary, or even middle school versus high school, by only bio teachers? Whatever that looks like, but think about if you would be interested in the learning community and what you would want to accomplish and how they might be organized. And so we'll reach out to you towards the end of the calendar year with next steps around that. And then the last thing I just wanted to put out there was going to run through a thank you from all of us at the CRS team. I'm embarrassing myself on purpose. This is me in 2nd grade displaying my science fair project, wearing the goofy.
You have to share it.
Oh, good. I didn't share it. That's probably good.
And we will share all of these resources with you. Yeah, the slide deck and everything, the video, the recording, everything.
Let me see. Sorry, I'm Zoom, still Zoom novice. But anyway, while we're wrapping up, yeah, please feel free to, here's screen share, got it. Sharing. I've learned that it's okay to embarrass yourself once in a while. So there it is. So thank you just for really teaching the students and learning yourselves about how to care for our planet. You know, we are in a very precarious moment in time as our youth are feeling and we're feeling, but there is hope, and we're all sort of shepherds of that hope, if you will. So really keep up the good work that you're doing. Look for those entry points and inspirational moments with your students and jump onto them, you know, because the learning will propel from that point, and they will be self-learners. And this idea of lifelong learning, if we can get to that point with our students, we've done a tremendous job where they just can continue to learn and engage and absorb, you know, and move forward. So thank you all. We're here. We'll hang out for 15 minutes, half an hour, if you've got questions about anything we've talked about, and really like next steps.
Thanks so much, Eric, for presenting, and we will look forward to remaining connected with all of you, and thank you so much.
Thank you.
Thank you. Bye-bye.
Thanks for all the good work you do, all of you. It's wonderful to know that you're out there.
Really appreciate it.
Thanks.
So Eric, thank you so much. And I have a question.
Of course you do, Kate.
Of course I do.
Eric, do you want to stop sharing or you want to keep sharing?